Algebra 2, 6.4a, divide a polynomial by a monomial. Okay, we're getting pretty far in Chapter 6 here. If you haven't seen the previous videos, I don't want you to get lost. So there's links in this video's description so you could watch those quickly so you can catch up with us. Remember, fractions are little division problems. Well, I've been saying that from every grade school playlist. Rational expressions are also division problems, and sometimes it's useful to do that division. We can divide a monomial by first writing a rational expression. The denominator divides each term of the numerator. If we divide a 3-term polynomial by a monomial, that's one term, our answer will have 3 terms. But our answer may not be a polynomial if it has negative exponents. So, take a look at this. Now, these are not polynomials, but I wanted to give you an idea of what we're going to be doing. If we have 8 plus 4 plus 6, and we need to divide it by 2, we can rewrite it as 2 goes into 8 4 times, 2 goes into 4 2 times, and 2 goes into 6 3 times, so we could have 4 plus 2 plus 3. We can also add the 8 plus 4 plus 6 and get an 18, divide that by 2 and it gets a 9, and you can see on the other side of the equal sign, the 4 plus 2 plus 3 equals 9. See? So we just divided each of the numerator's terms by that denominator term. See that? So that's what we're going to do, except we're going to do it algebraically with polynomials and a monomial. Now, take a look at this. It says to divide 12x to the third power plus 8x squared plus x plus 4 by 4x. So the first thing we're going to do is rewrite it as a rational expression. Okay? So we're just taking this whole thing and making it the numerator and making that the denominator. All right? So if you watched the video from 6.2a, you saw this theorem, and we talked about it, and we had a lesson on this. It's the addition of rational expressions. That for any rational expressions, if we've got 2 rational expressions with the same denominator, as long as that denominator is not 0, because that'd be undefined, right? We could take these and write them over the fraction bar with the c, see that? As just one term in the denominator. Same thing with subtraction. We could do a minus b over that c because the denominators are the same, okay? So that's what we're going to do here. We're going to take this polynomial over this monomial, and using that theorem, we're going to split it apart, okay? That theorem, it said we could put it all together, but we can also split them apart. So we can turn them into 4 different little division problems. See that? This 12 divided by 4 is going to be a 3. And remember that quotient rule back in Algebra 1, 5.1b, we learned about subtracting exponents. And there's going to be a link in this video description for that too, in case you forgot back from Algebra 1. But if we have x to the third, and this is x to the first power, isn't it? Then we do 3, take away that 1, which gives us x squared. We do the same thing with each term. 8 divided by 4 is a 2. X to the second power, take away x to the first power, it just leaves us an x to the first power. This gives us a 1/4 because these two x's cancel out, don't they? And there's an invisible 1 coefficient in front of that x. And this one ends up just becoming a 1 over x. All right? So what we did was we divide each coefficient of the numerator by the coefficient of the denominator. See? That's how we got the 3. And we subtract the exponents. See? That's pretty easy, isn't it? Makes sense. All right, let's try another one. Here's our polynomial in parentheses, and we've got our monomial x squared. We're going to rewrite it as a rational expression with the fraction bar and the x squared underneath as the denominator. Using that theorem, we're going to split it apart. Notice that we have a subtraction sign here and an addition sign there. And if there's an invisible 1 coefficient in front of this x, then we're saying 8 divided by 1, which is an 8, isn't it? That's going to give us an 8 there. And we've got to subtract the exponents. So we're basically saying we've got an 8 x to the 4th power, and we're taking away that x to the 2nd power. So that x becomes a 4 minus 2, doesn't it? See? Using that quotient rule, subtracting the exponents. Here we have a 3 minus 2 for our x. And here, these two cancel each other out, so we just have a 5. It would be like a 5 over a 1, wouldn't it? So it would be a 5. This is going to give us an 8x squared minus 3x plus a 5. See? So just remember that x is the same as x to the first power. Remember there's a 1 coefficient in front of a lonely variable. And we actually learned this back in Algebra 1 video 10.9, and there's going to be a link in this video's description for all those Algebra 1 videos that correlate with this one, okay? I'm going to add this video to the Algebra 2 playlist and all those previous Chapter 6 videos that we just did. Our next video is going to be 6.4b, and we're going to divide a polynomial by a polynomial. Not a monomial this time. It's going to be bigger, okay? So I'll see you next video. I hope you're doing well. And keep watching each video. And don't forget to hit the like button if I was able to help you. And don't forget, I'm on Patreon.com. And Bitsy and Lola and I could really use your support. Bye.